thank you for joining us today. We will be speaking with Dr. John Z. Lang, who is a co-author with me on the recent GWMR Advances in Remediation Solutions column titled Solutions for Managing AFFF Impacted Infrastructure. John Z., thank you for joining us.
Thank you for having me, Craig.
Well, let's just jump right into it. What is this problem around AFFF impacted infrastructure, and what are some of the topics that we cover in the article?
So recently, users have started to transition from PFAS containing AFFF to new PFAS-free firefighting formulations. And it's important to do this process properly, because if you don't, then you're going to end up with rebound of the PFAS from the wetted surfaces of the infrastructure into your new foams. And so we're really, in this article, are highlighting things that, are important to consider when you're making this transition. And not just from wetted surfaces, but also as you transition, thinking about things like concrete surfaces, which have been impacted over the years with use of AFFF. So essentially, as you transition from a PFAS-containing AFFF, making sure you get all of that out of your facility as you make that transition.
Yeah, that makes sense. So what makes PFAS difficult or unique challenges with regard to removing from historical legacy infrastructure?
So PFAS typically have a long hydrophobic tail, the fluorinated tail, and then they'll have a hydrophilic head group. And because of this orientation, they like to layer. And so they're going to line up with the hydrophobic ends facing towards each other and the hydrophilic ends facing out. And this layering can happen over time in exposure to wetted infrastructure, as well as things like concrete, which may have repeated use of AFFF on the surface. And essentially, these layers build up. I like to think about it as, when you cook bacon in a frying pan, it's not easy to get that leftover bacon grease off. You can't just run water over the surface of that frying pan. You need to add some sort of soap, and a lot of times really a little elbow grease, and get in there and actually do some sort of scrubbing action. PFAS are similar to that. They've got this kind of coated hydrophobic surface on them that really don't respond well to just water flushing.
Yeah, that makes sense. So what does a successful process look like, and how do we verify success?
So there's a lot of things that go into the transition process up front. There's a lot of planning. A lot of times with fixed systems, insurance companies are involved on anything related to a fire suppression system. But once you get on site, actually, the process is relatively simple. We're going to show up, or other companies that provide cleaning services will show up. They'll essentially clean the system through a variety of flushes. And, we typically do a water flush at the initial and final step to verify the cleaning process. But the actual cleaning process for us is accomplished with a proprietary cleaning agent called Fluorifighter. There's others on the market. For example, perfluoride is offered as another alternative to try to really get in there, and you need to really disrupt these layers of PFAS and remove them from the system. So there's a variety of different performance goals, and we really tried to talk through these with clients. It can range from anything to, rebound testing. So you can go and look at how much PFAS are rebounding into either a water flush of the system after it's been cleaned, or into the PFAS-free firefighting formulations. Or we also like to think about it as how much mass has been removed from the system. So as I said, water isn't a great constituent for dissolving these layers. And so really, we like to look at how much mass we're removing in the cleaning step. And so it's kind of mass out equals less mass that could rebound. And so we look at both rebound into a variety of different aqueous solutions, as well as the mass removed.
So during these change out activities, of course, a lot of waste is generated, and in many locations we have legacy stockpiles of AFFF. What are some of the solutions for managing this waste?
So there are a variety of different options for disposal of either AFFF concentrate or waste generated from the cleaning of these systems. And I will say that I think, over the last 10 years, as far as destruction methods go, so this is what I'm counting as PFAS methods where there is complete mineralization of the PFAS. I think they've really come a long way. For example, supercritical water oxidation, or SCWO, is really a commercially viable method now where you can send, AFFF concentrate for SCWO destruction. And, there's always the old, landfill. It's kind of an older technology now, but we do see particularly hazardous waste landfilling occurring from a lot of different people. One thing that's interesting is that people are actually we're seeing paying quite a bit more for SCWO compared to landfilling. And this is because with SCWO, when you drop your waste off, you get a certificate of destruction, which shows that your PFAS has been destroyed back to its mineralized form. And therefore, it really releases you from a lot of the liability that you may have when you're putting a PFAS, undestroyed into a storage situation like a landfill.
Yeah, I think that premium is going to persist for some time and be substantial. There is a lot of value in having confidence that you've completely retired the liability.
Agreed.
So, Johnsy, let's talk about locations where there were fire training activities to prepare teams to extinguish fires, where there was a set aside location and routine practicing of the use of AFFF in live scenarios. What are the risks with AFFF that's been deployed there, and what are some of the solutions?
So when you have a situation where you have a hardscape like concrete, where you've had repeated use of a PFAS containing AFFF over years or even sometimes decades, you're going to have that same buildup effect as I was talking about on the wetted surfaces of fire suppression infrastructure. So you're going to have this buildup of PFAS layers there, which will be, somewhat hydrophobic. And just a water flushing of that concrete probably, isn't going to remove all of the mass. We have seen a variety of solutions towards dealing with PFAS impacted concrete. It can have like a sealant placed over top of it, which essentially prevents PFAS from migrating from the concrete out into the environment, holds it in place there. We've also had our fluorifier cleaning agent used to clean concrete sewer pipes. So really trying to go in there once again and break up those PFAS layers and remove as much mass as possible. And, finally, if the concrete is what's impacted, you can always dig the concrete up and remove it. I think, full removal of concrete is one way to get that PFAS mass that's built up there off of your site.
Well, Johnsy, thank you for your contribution to this very practical article. I think foam changeout is an activity that we're going to see more of for the next number of years, and developing best practices and real-world solutions is critical for our industry.
Thank you, Craig, for giving me the opportunity to come on and talk with you about it.